Here we continue the next point, electric potential due to electric dipole. In that case, you must know what is electric dipole and how it is formed. Electric dipole is formed due to the two opposite charges separated by very small distance. Here the two charges plus q and minus q separated by the distance 2a, it form a electric dipole. Such a dipole has dipole moment denoted by the vector p, and it is directed from minus q to plus q charge. Therefore, what is its magnitude? Magnitude is charge multiplied by 2a. Nextly, we find what is the electric potential at point C. That point C is at a distance r from the center of the dipole. We also join the point C with this point A where plus q charge is situated, and point C to point B where minus q charge is situated. Therefore, the distance AC equal to R1 and BC equal to R2 and OC is R. Therefore, the angle COA that equal to theta, and we suppose here R is very greater than A. Then we find electric potential at point C due to the two charges separately. Hence, for the charge plus q, electric potential at C is V is equal to q divided by 4 pi epsilon 0 into R1. That relation we derived earlier. This is due to plus q charge. Similarly, due to minus q charge, electric potential at C is equal to V is equal to minus q divided by 4 pi epsilon 0 into R2. Therefore, electric potential due to electric dipole at point C becomes sum of the two terms. V is equal to q divided by 4 pi epsilon 0, take common inside the bracket, 1 by R1 minus 1 by R2. Say equation 1. In that equation, we find the value of 1 by R1 and 1 by R2 by using the geometry. In that geometry, what is R1 square and R2 square that we define. R1 square is equal to R square plus A square minus twice AR cos theta. Now simplify that equation on one side, take common R square and rewrite the equation. R1 square is equal to R square into bracket 1 plus A square by R square minus twice A cos theta by R. Here the second term A square by R square we neglect since R is very greater than A. Therefore, the remaining term becomes R1 square is equal to R square into bracket 1 minus twice A cos theta by R. Here we take the reciprocal of that equation and cancel square on both sides. The equation becomes 1 by R1 equal to 1 by R into bracket 1 minus twice A cos theta by R raised to minus half. We use the binomial expansion for the bracketed term raised to minus half and write only first two terms. Therefore, 1 by R1 is equal to 1 by R into bracket. First term 1, second term is minus minus become plus, since minus already raised to minus half plus A cos theta divided by R. Two numerator denominator cancel. This is the equation 2. Similarly, we also find 1 by R2. Hence, again use the geometry of the above figure. R2 square is equal to R square plus A square plus twice AR cos theta. In that equation, on one side take R square common and A square by R square neglect as like earlier step. Therefore, the R2 square is equal to R square into bracket 1 plus twice A cos theta divided by R. Again, take the ratio, cancel square on both sides and simplify the term. It becomes 1 by R2 equal to 1 by R into bracket 1 plus twice A cos theta divided by R raised to minus half. Use binomial expansion, binomial theorem for the bracketed term raised to minus half and write the only two terms. Therefore, the term becomes 1 by R2 is equal to 1 by R into bracket 1 minus A. Since here is raised to minus half, hence we write the minus A cos theta 2 cancel to the numerator denominator divided by R. Equation 3. Now from equation 2, 3, we simplify the equation 1. Equation 1 is known, V equal to Q divided by 4 pi epsilon 0 into bracket 1 by R1 minus 1 by R2. Put the value from 2 and 3 and simplify the equation. Inside the bracket 1 by R minus 1 by R cancel and add the second and last term. Q divided by 4 pi epsilon 0 into twice A cos theta by R square. That gives the electric potential, total electric potential due to electric dipole at point C. Again we simplify in terms of dipole moment. Magnitude of the electric dipole moment is P is equal to twice AQ. Therefore, the numerator term is Q and twice A. Multiplication, it becomes P. Hence, V equal to 1 divided by 4 pi epsilon 0 into P cos theta divided by R square. And that is the required expression for the electric potential due to dipole moment. Now we explain some cases. Electric potential at point C depends on theta. Means as theta is 0 or 180 degree. Means what? What is the position of the dipole? We find the electric potential along the axis of the dipole. Means point C is along the axis of the dipole. What is its electric potential? If theta is 0, cos 0 is 1 and remaining term becomes 1 divided by 4 pi epsilon 0 into P divided by R square. If again it is pi, it is minus 1. Hence plus minus 1 divided by 4 pi epsilon 0 into P by R square. It represents electric potential due to electric dipole if the point is along the axis of the dipole. That relation is also important to solve the problems. At another angle theta, if theta is 90 degree, means what is the position of the axis of the dipole and the point P? Both are perpendicular. That V is in the equatorial plane and along that one cos 90 is 0. Therefore, potential in the equatorial plane is always 0. Nextly, we find what is the electric field due to electric dipole. Potential is known, then it becomes easy to find electric field. How we find the electric field? Electric field E is equal to d by dr of electric potential. But that electric field at C is resolved into the two components. One component is along the radius vector and along that vector the electric field becomes a radial electric field equal to minus of dV by dr, where V is the electric potential. That value is known. Therefore, differentiate V term with respect to R. Equation becomes 1 divided by 4 pi epsilon 0 into bracket 2p cos theta divided by r cube. And second component, which is perpendicular to the radius vector, means that is E theta, since this makes some angle, that is equal to minus 1 by r into dv by d theta. Again differentiate V term with respect to theta and it gets simplified term p cos sin theta divided by 4 pi epsilon 0 into r cube. Hence, electric potential due to electric dipole resolved into the two components. One is along the radius vector and other is perpendicular to the radius vector. That two relations we also find if we know the electric potential at the point C. And what is the effect of angle on the electric potential? If theta is 0 or pi, electric potential must be plus minus 1 divided by 4 pi epsilon 0 into p by r square. And if theta is 90 degree, then electric potential is to be 0. And this is the today's article and its result. Thank you.